Okay, so we are going to continue the part number 4 of your probability and statistics. So we cut off last time here, yeah? So we will continue in a part 4, the area in an interval. So let's see how we do it. So we can visualize this area in an interval under the curve. So this yellow part, yeah, under this curve. So you can visualize that, but actually you can calculate the area from the distribution function. Yeah, it's somewhat difficult and inaccurate because like I just showed you, right? We use a z-table and then we calculate it, but I am going to show you another way, yeah, how to do it from the point of pure mathematics. Okay, so you need to know everything, your foundations. So let's take a look at it. So if we go back to the pure mathematics and like how this distribution curve. So when you look at this distribution curve, the equation for that curve is this. Okay, so you have your function z, yeah, and that's what we call z-table. All the numbers that you got in z-table come from calculation, right, out of this mathematical formula, which is your equation. All right, and so you can see another area here, the little yellow one, yeah. So the equation for this area, equation meaning like we use this mathematical model or equation to calculate, all right, to calculate this area, and that's what we're talking about. And we have to use calculus, you know, because you're dealing with a curve, okay. We're not dealing with a regular square or circle to get the area, yeah, because you have see this little curve, so you have like a shape to get this, yeah, area, and that's the reason why you're seeing, okay, function, which is a little bit complex for you here, and because we get into the calculus area to get the area under the curve, okay. And don't forget we're trying to get the cumulative distribution function, which is your CDF. We call C for cumulative, D for distribution, and F for the function, yeah, for a normal distribution. So this equation, again, is formally we call it, you know, the distribution curve or probability density function, okay, which is PDF. And that equation show you the probability density function in your PDF for a normal distribution, which is this. Okay, you know what a normal distribution is. So it's definitely describe the shape of that normal distribution. Shape meaning from here going down and down like that. Okay, of course, it's slightly different. And the function is going to give you the probability of a random variable z taking on a specific value. You know. So the z value is going to give you, because it can be anything, yeah, under this curve. When we talked about probability mathematically, we are actually getting the area under the curve, okay? So make sure that this is for the entire curve, which is your normal distribution, and that is a particular area, yeah, under the curve. So this equation, so if you come into here, and this is a CDF, which is your cumulative distribution function, yeah, for your normal distribution. It represents the area again under the curve of your probability distribution function, yeah, from negative infinity to a point. Okay, that's we usually call that point a z point. Yeah, that z, of course, is a number under in this distribution. So this probability that a random variable z is less than or equal to, yeah, to the distribution data point here, the cumulative distribution function is going to tell you the cumulative probability up to a point on that curve. Okay, they're just we're just taking a point, because you have to take a point in order for you to get a probability. Yeah, like 1 out of your 6 phases of your die. Yeah, like that. So 1 point out of all the points that you've got here, and you're looking for the probability of that data point or data points, okay, range of data points, by using this function here. Yeah. Of course, we can get the entire area like this. We can also get the regular point data. Yeah. So this normal distribution curve is our regular normal distribution, and then it's going to show you the probability density. So density meaning the height of your curve for various standard deviation, which these sigma values right here, and the yellow shaded area highlights the one standard deviation because away, this is your mean, and one standard deviation away from the mean, starting from there all the way down to the end. So that is between minus 1 sigma, minus 2 sigma, all the way to minus 3 sigma. So this represents about 15.9% of the total area, I would say, because from one standard deviation about 68, so from here to go all the way down, so about 13 here, and then 2 point something here, so about 15.9% of the entire distribution is under this yellow curve. So this guy is just showing you, your cumulative distribution function increases, it's going up, showing you that it increases as you move from left to right, on the x-axis. So this is your x-axis, so which represent your standard deviations are on your x-axis, and the curve rises, as more area under your probability distribution function is accumulated. And it approaches 100, of course, because the entire normal distribution has like 100% as you get further off from the mean. So the highlighted area, about 15.9%, correspond to the probability within from here all the way to here. So if you think about the cumulative distribution function, CDF, it's just a function that's going to help calculate your cumulative probability, that a variable is less than or equal to a certain value. So this is for example, you can calculate the CDF of a variable, and you can be able to say if that's less than or equal to a certain value, and that's very useful in calculating probabilities. Of course, today we use Excel or computation devices and programs to be able to bypass this tedious pure mathematics calculation by using the equation like in old days. So this is just telling you that you don't have to worry about tedious calculation by using the mathematical models in our line. Of course, if you take a pure mathematics with general, some of the major need to take a general mathematics, and they're gonna make you do this by hand sometimes, depends on the professor. And of course, here in my class you don't need it. You will have to use your Excel, because nobody in our field use handwriting calculation because it takes a long time, and we have to deal with in manufacturing. You have to deal with thousands and thousands and thousands of data every day. So therefore, you definitely need to use your Excel, or more powerful computation programs. So anyway, so this second function, and the curve, they are already implemented mathematically in your Excel calculators and computation programs. So you can easily get the cumulative distribution function probability. And I'll show you a long time ago, they use the Z tables, paper ones. Go to the tables and read the values like that. There's a slight difference in calculation, of course, with the computation device. Okay, so let's go into cumulative distribution function. It's going to tell you how much area is under the curve, starting from the left, going this way. So if this example question is, what's the probability that your variable falls in the range from minus infinity, coming all the way from the minus infinity and approaching this line, which is minus 1.5 standard deviation. This line is a minus 1.5 standard deviation because it's 1 here and 0.5 here and 2 here. So there is no confusion of where this minus 1.5 come from. It comes from the graph, and we put a yellow area right here for you so you can visualize it. So first you're going to look at the minus 1.5 sigma on the lower curve, and then you're going to read over to the percent scale, Percent scale is this graph that's been given to you right here. So that line is going to show you that it's about 6.68%, which is the area, calculated area under that curve. Yeah, so that's your probability. So the area of the yellow interval above is 6.68% of the total area. Yeah, 6.68% or 100% total area of this normal distribution curve. So the variable will fall into the yellow area if you choose, whatever you're studying. So we're in the shift diameter. So if you choose a shift diameter, and that shift diameter will go into this. So the data point that you chose, okay, could be in here about 6.68%. Yeah, but you have 100 minus 6.68%. The data point that you pick out, yeah, could be in this area because it's a wider area. Yeah, so it has more percentages, more chances for that whatever you selected be in this area. But for whatever you have selected out of that 1000 shaft, okay, the diameter that you have selected, that shaft, could be in this area about 6.68%. If we had to use the same problem. I think you kind of get it. Now we're going to increase the area, so go all the way to negative infinity to the -1, okay, sigma on this side. So that's about like a 15.9%. The same thing, you pick a shaft, and that shaft diameter, okay, is gonna show up here, and the chance for that diameter to show up is a 15.9%. Meaning what you pick out is going to be, okay, around that diameter range. Because remember, we have a diameter for your shaft, 27.1, I think, is your average. Yeah. And then there are many different diameter that you get. About 1000 data points are in there. Yeah, so whatever that you pick, the diameter can be in this area, about 15.9%. Yeah, then we're going to increase the area all the way to the mean. Yeah, and so that's when you get to the mean, you have like about 50%. Yeah, so 50%. 50% on chances. So therefore the area of the yellow interval, okay, is 50%. The probability, this is our probability cumulative distribution curve, and the probability that the variable will take on a value in that yellow area is 50%. So the variable is going to fall into the yellow area 50% of the time. Okay, so now you're kind of okay with the terms that we use to interpret the two graphs. Yeah, this is your normal distribution, and this is your cumulative distribution curve. And then we're going to increase the area all the way to the positive, infinity sign. So we go 1.5 positive 1.5 sigma, and by the time you reach there, you have about 93.3%. So the area of the yellow interval above is 93.3%. The probability that the variable will take on a value in the yellow area is 93.3%. Okay, so the variable is going to fall into that yellow area 93.3% of the time. Yeah, so I think you totally get it. Now we're going to go a little bit over 2 sigma. Your area is now increasing, yeah, to 2 point something sigma here, this cut line. And when you look at the cumulative distribution, we know that that's like 98.6%. So the variable will fall into the yellow area 98.6% of the time. Yeah. So now we're going to cut it off from starting from here and cut off here. So that's okay. You will have to do a calculation because we're not starting from the negative, infinity. We cut off from here and cut off from there. So therefore, in order for us to find this area, you have to do a little bit of a calculation. So again, the same thing. What is the probability that the variable is going to fall in this range from -1 sigma all the way to 1 sigma? Okay, standard deviation. So your answer is first you're going to look at +1, right? Probability, and that's 16. Yeah, and the other one is cut off right here at 84. So that's a plus. +1 standard deviation. -1 standard deviation is going to give you a 16%. Yeah, so therefore you're going to minus 16% out of 84%, so you're going to get about 68%. Okay, for this yellow area. So you know that the variable is going to fall between these two limits 68% of the time. Yeah, so you have 68% of the shafts will have a diameter between 27.05 all the way to 27.15. So this is what I was talking about. Yeah, so the variable that you're looking for. Now we wrote it here, and here there wasn't. Yeah, so right now, so you know that we're talking about the shaft diameter. So the shaft diameter 27.05 to 27.15 is your variable choices, can fall 68%, okay, of the time. So that's the probability of getting from here to here, yeah, in your shaft diameter. So in other words, 68% of the shaft will have a diameter between 27.05 to 27.15 millimeters. Okay. All right. So now here you can look very carefully on this two. All right, graph. So one is a normal bell-shaped curve, which is your normal distribution. The other one is a cumulative distribution function curve, okay, which is your cumulative probability, and the standard deviation away from the mean is drawn against. Yeah, and that of course corresponds to the area that we are dealing with in our normal distribution curve. And we're going to reflect on what we just did, yeah, starting from the negative infinity and cut it out at the negative 1.5 sigma. So negative 1.5 sigma is right here, and then we draw the line, and we're going to read, okay, because your y-axis is accumulated probability, so you can easily read it, and that's a 6.68. Yeah, if you were to do it manually. Yeah? So now we increase to minus 1 sigma. Minus 1 sigma is 15.9% by using this cumulative distribution function y-axis. Yeah, then we're going to increase again to mean, and the x bar is your mean, which is okay. You will definitely have whatever you're studying variable here, which is in this example is a shaft diameter. Yeah, your 27.1 millimeter is right here at the mean. So to get that, you have about 50% chance to get that diameter of the shaft. Okay, then we go to the next area. We're going to cut off as a positive 1.5 sigma, and that is 93.3%. Then we're going to increase the area. We're going to cut off like a plus 2 point something percent right here, and plus 2 point something sigma right here, and that is 98.6% for the cumulative distribution. And then after you have studied that, you know, okay, of course, about this two mathematical models, which is your equation. This, okay, is this curve, which is your normal distribution curve, and then that is this curve, which is your cumulative distribution, okay, curve. And this is going to give you the probability according to the sigma, yeah, that your normal distribution is playing with. So so we don't really calculate the probability using the graphical charts, although this does provide a very good estimate, yeah. Before of course, this is like talking about a long time ago, before we have computers and calculators, probabilities. They do it in the book. Okay, right now we don't need to do that kind of stuff anymore. Yeah. So instead of looking at a chart, right, we look at the probability in large tables in the book. So this is the old days, yeah, and how they calculate, yeah. Nowadays students are very lazy. Yes, I am included in it too. But anyway, so we use a calculator, Excel. We use yes, other computation, languages and devices and programs. And I've already shared you about the statistical software, your Minitab, your SPSS, and I'll also give you other software, but you don't need it for now. If you have like Excel, Minitab, and SPSS, is more than enough, yeah. And of course, by using the computational programs and devices, so we can easily calculate this probability. And I have just to show you how to do it in your Excel. It's a very, very simple function right here. Yeah, NORM.S.DIST is your simple normal distribution. Yes. Okay. Now we're going to go back in history. So early methods are you use a handbook. So look at this, a very, very old book that you can get in your library. Yeah, so you can go and find it and take a look at it if you have time. So you have a probability statistic book, and I just show you the Z table and show you the example calculation how to do it. Right here with the Z table on the paper. And that is what you can be able to see the standard normal the cumulative probability table, so which is your Z table because we code it with a Z. Yeah, so that's before the days of the computers. Instead of using a computation device, that you look at a chart like this to calculate that too. And here is a sample reading. So if you have a sigma is a negative side 2.53, we go to the negative side 2.5 and then go 0, 1, and then 2, and then 3. You're going to get like 0.0057. Yeah? And that is turn that decimal into a percentage, and you get 0.57% of the parts for that area. Okay, so this is a historical to modern methods of calculation probability, and your book long time ago, and then your calculator for high school people, and then your Excel starting point of your college. Yeah. So what's in it? So we program this equation into it. Yeah, and this is machine reading it, and the machine can read something like that, and then it's going to give you something like this for the human visualization. So that's a machine language, a human language. From human language, you click, 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 and change into machine language. Machine calculate and give you back. Okay, and you see this display. Same in the Excel. Yeah. On the internet, also, if you browse, browse it, and you're gonna see so many interactive, that you can input, and it's gonna give you your NORM.S.DIST, for example, Z. You give Z values, and you're going to get the probability out of it. So there are many ways. And also some platform like website, if they have time, they're going to create something for you that you can use. Of course, right now we're in AI, so as you go to your chat and then ask blah, 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 and it's going to give you that. Yeah, it might not be very accurate, but you will get a relative estimate out of it. Okay, in the world we have real dimensions, so our dimensions are like in millimeters, inches, things like that. So that's our physical world. So real world measurement and dimensions. So here so example is fabricated parts. So your process the process mean is mu, and you have like a 62 millimeter, and standard deviation calculated for this example is 0.2 millimeters. Yeah, so and your and this area is going to go from 61.45 all the way to 62.55. Okay, and your mean is right here, 62. Okay, so the customer wants to know, what percentage of the parts will be between 61.45 millimeter. So 61, you go for it. So 61.45, so which is this guy, and all the way to 62.55, which is this guy. So this area, okay, basically you gotta find the probability of that. Yeah. So historically, we could not ask the two, meaning like we can use a program, or we can use an Excel or calculator or tables. Yeah, this question are directly in millimeter. So let's take a look at it. So a long time ago, it's really impossible, for us to be able to calculate even playing with 4 dice. You have 12, right? 12, 96. I'm gonna just go back and show you. So that's many combination. So it's impossible, without the a computation device or program to come up with that many combination. So that's every conceivable combination of mean, and it's really difficult. So we're gonna find a special case, something called the special cases. Mean is 0, your standard deviation is 1. So we're gonna make it like this instead of real world example like that. Okay, 62.2, and we're gonna standardize by using mean at 0 and our standard deviation of this. So here is what we're trying to initialize. So how do we come up with this table? Alright, that we got everything to deal with, is because the table, if you look carefully, and we are actually using the standard deviation of 1 and the mean is 0. Okay, so let's get into that a little more. And where's my stuff? Okay, so we're here, and then of course we're getting into the real world. Was this one? and then we're going to compare that to our standard version, which is 0 and 1. Here's a real world 62 millimeter with 0.2 millimeter, stuff like that. So we have to convert from the dimensions to the standard deviation to use, all right, the tools. So here probability tooled, and then this is a probability tool world where we're going to create, okay, all of this, a program, calculator, Excel, so and so in the book, of course. So how are we going to do that? So let's start beginning. We're going to give it a mean 0. We're going to give it a standard deviation 1. So that's mean 0, standard deviation 1, 2, 3. So algorithms or tools for calculating normal distribution probabilities, implement only one special case to simplify calculation. So the gist of science is we make things so simple. So if you pay attention, almost all the professors, everybody who study, they're gonna say everything is easy. Why? Because we simplify everything. We make things easy. And outside world is make things so complicated. So when you come to college or university and you study, you are learning from the professor. Okay, and the only thing that we're trying to teach you is how to see the world in a very simple way. Okay, if you have like a complicated problem, you're going to simplify everything, so it's easier for you to be able to solve it. Okay, you might not be human because we are getting rid of eliminating all the human factors, like that. So you can solve almost everything, every situation, every problem by using a scientific method of simplifying it. Okay, so exactly that here in normal distribution calculation, we're going to simplify everything. We're going to make the mean 0. We're going to make the standard deviation sigma 1. So that's the beginning of starting point of coming up with all these good things. So and then the 2 assumes the mean is 0, the standard deviation is 1, and we have to give it inputs in terms of how many standard deviation away from the mean. We cannot give it inputs in terms of actual dimension because it will complicate everything. Because your actual dimension can be many things. The human world has so many things, it's just so complicated. The scientific world, we simplify everything, and it is easier, for all of us to handle. So in the example above, we're asking the tool what percentage of the parts will be smaller than 1.75 sigma above the mean length. Okay, so here is the mean, and we're going to go 1.75 sigma above the mean length. Okay, so we're going to ask the tool what percentage of the parts will be smaller. So we're going to start calculating, okay, and going back to our from here, standardization into here. So here, your real world problem is I have a mean of 62 millimeters and the process is 0.2. So the customer wants to know what percentage of the parts is going to be 61.65 all the way to 62, okay, 0.35. So we cannot ask the tool, this question directly. So the tool is going to think. Tool mean your calculator and your Excel. So all processes have a mean of 0 and a standard deviation because that's how we program it. Okay, so we have to translate these dimensions from millimeter to standard deviation relative to the mean. So that's the first thing that we do. Okay, in these programmed calculation that they are doing it. When you input it here. So first, what it does is it converts the limits to the standard deviation away from the mean, and converts the limits mean this one. Okay, the standard deviation away from the mean is here, and how many standard deviation that you go. So here, when you look at it, 62 to 61.65 is about 0.35 millimeter below the mean. Okay, so here's the mean, you calculate it, and you got that. And your standard deviation is 0.2. So we're going to find out how many standard deviation that we went from here to here. So you divide 0.35 by 0.2. It's going to give you 1.75 sigma below that mean. Okay, so we go minus 1.75 sigma. And we do the same thing on this side, the upper number, going all the way from mean to here. How many sigma we calculated, use this. And first you calculate the distance from here to here. Divide that distance by using your sigma cut point, which is 1 sigma is 0.2. So divide with that, you're going to get 1.75 sigma away from there. We already know that in the calculator and the Excel and so many program, we make it 0 and then go 1, go 2, go 3, like that. So right now we transfer our physical millimeter into the standard time. So how many sigma that we go by calculating using this given standard deviations in the problem. So we get, we went 1.75. We went 1.75 on both sides. So that's what we get. So then we're going to come back here and use the input, which I have already shown you, norm, and then .s, .dist, which is this guy that I just showed it to you. I'm going to go back here, this guy right there. So we're going to input that and give that standard deviation, which is 1.75, and then make it a true. True is calculating the CDF, your accumulated distribution function is true. And so we're going to get probability, which is 0.9.994, and turn that into percentage by multiplying that with 100. So you're going to get 95.994%. Okay. So we do the same thing to the other side. Okay, so to the other side you have a minus. So see, the differences are positive and differences negative here. So if you put the negative input, you're going to get your percentage is 4.006. So see that, so that's the area that you get on the negative side. So if you get the negative side, if you want, of course, in here, you have to cut that area out of it. So you will, minus that area out of that. So you're going to get this, okay? So the first NORM.DIST is going to give you from here to here. Second, going to give you from here to here, because our measurement always start, reference point is the left. So the left going to start and initiate the area and go down, 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 down all the way here. It's going to stop at positive 1.75. And the whole thing is 95.994. Now we're going to start from our reference point 0 and then go down, 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 down and stop as negative 1.75. Okay, when you get to negative 1.75, the area is 4% about. So you're going to minus this area out of that area. So when you minus it, you get from here all the way to here. Okay, and that is 91.988%. Okay. So I think you kind of get it. So I think the confusion for the student is when you put this, NORM.DIST, you got a value and you don't know what that is. And this is the area, and you have to start from your very left. Okay, your reference. Reference means where did you start to draw this area? You start from the reference point on the left, okay, which is the beginning of this little tape. And then go all the way and cut it off where? Cut it off right here at that standard deviation. Okay, so here we go all the way to positive side. Here we stop at the negative side. So if you stop at the negative side, you're going to go a little area because our starting point is on the left. Okay, if you go all the way to the positive area, positive standard deviation, you're going to get a big area because your starting point is on the left. The beginning of the reference point is the end of this little left tail. Okay, so that is your confusion. Yes, so therefore if you want the middle area, all you have to do is take this area out of that. Okay, and you will get the middle area. Okay, so now let's get into calculating probability in Excel. So easy. All you have to do is just a norm. We're dealing with a sample, always a sample. So therefore do not have a confusion with a normal regular, okay, NORM.DIST. So you do have a normal NORM.DIST right there, so I am going to show you that. Okay, so here see that returns a normal distribution for the specific mean and the standard deviation. So if you click on it, you're going to see mean, standard deviation, and then cumulative. So we don't want that. What we want is this guy. Okay, see the S and how different, so S is in between, and we are going to put only our little Z. So Z value, which is your a sigma value, which is your standard deviation value, and then you accumulate it. So if your sigma is on the positive side, let's say, okay, 0.5 sigma, and then your cumulative, you have two. False is probability density function that I just explained that to you, your PDF. And then true is cumulative distribution function, which is CDF. This is under the curve that you want to cut off according to this, all right, standard deviation, which is your Z. And that is the entire thing, your probability distribution function, and you're not in there yet. Okay, you just get started. So make sure that you give a true for finding an area and with a particular standard deviation. Okay, so make sure that you understand. So PDF is what I have to go back, and when you go all the way into here, we gave you a little bit on the PDF, which is around here we started. Okay, probability distribution function, which is actually this guy. Okay, so anyway, so let's go back all the way to the back to where we were here. Yes. So one student asked me the difference between the PDF and the CDF. So CDF this equation, PDF this equation. Yeah. So PDF is your probability distribution function curve, which is this guy, and that's gonna just integrate to 1 over the entire range, which is this. Yeah. Because the total probability is always 1 here, 100%. Yeah. Cumulative distribution function is this guy. Yeah. A very different equation here. And you can see that, and your CDF represents the cumulative probability that your random, variable takes on a value less than or equal to a particular value. So it's like the sum of all probability up to a certain point, like we cut this off, see, up to a certain point, not the entirety, which is from here all the way to n is your PDF, and your CDF is from here to where you cut it off. Okay, so that is the difference between them. And of course, your cumulative distribution function is going to give you the your probability, cumulative probability value, the one that we just calculate. So which is going to help you in determining like how likely it is for your random variable of your choice to be less than or equal to a specific value. Okay. So anyway, don't forget that. Okay, so now we come back to this Excel function. Yeah, so this one is going to give you your z. This is your standard deviation. Okay, the one that we just input. You have plus and minus. So make sure you will put the plus and minus into it. And your true is going to give you cumulative distribution function. Your false is going to give you probability distribution function. This one is just telling you how we do this so how I am having a little bit of trouble writing this, how to do this. Okay, so hard. So anyway, can I do this thing? Okay, so I want to show you to draw. So we're gonna just draw it with this so you can see that this is the very first one. It's just telling you, oh, we're gonna use this equal to that, to get the probability, meaning like from left. Okay. So if we want to know the probability that a variable is going to take on a value, okay, to the left of a given number, meaning like that. Okay, so we're trying to find this area, and we're going to do this NORM.S.DIST. Okay, NORM.S.DIST. And if you want to get the probability variable takes on a value between the two limits, okay, like this. Okay, so if you want to get that, because first you have to find from here to here, and second you have to find from here to here, and then you have to subtract this, okay, out of that. Okay, and that's what it's talking about here. Because again, our reference, the starting point is here. So every time we call the NORM.DIST and calculate it, you're getting the area starting from this reference point here. So you will get from here to here, and then you will get from here to there. And you have to, of course, take this out of there in order for you to get this area right here, because your interest is getting this area, not that. But when you call the norm.dist, you will be getting area from here to here, and you'll be getting area from here to here. So therefore, you have to chop this area out in order for you to get the intervals right there. Yeah. I'm gonna go ahead and erase this. Okay, this is an example of what's available online. Yeah, I told you in addition to Minitab, SPSS, we have Excel, and you have some calculator that other courses is gonna assign you to calculate. But in our course, we use only Excel for that. And I also want to give you an example of one of this website. Yeah, you can use it for calculating the probabilities. So here we are in this online stat book, .com, and you can be able to try to find what you want to find, the probability, the area, like that. So your mean is 0, your standard deviation is 1, so that's your parameters. And then you have your above 1.96, below 1.96, okay? And then between is minus 1.96, and we can be able to calculate, the result of that, okay? So let's calculate. We're going to change it, okay, according to this example. We're going to change it to minus 1 and then minus 1.96. So let's go back here and change that to minus 1 here. Yeah. Then we're going to change this to plus 1. Yeah. And then we're going to go ahead and calculate it. Yeah. So what you got is, see that area? So that means that your standard deviation going from minus 1 all the way to 1, okay, is going to give you this area, okay? So that's pretty easy. Yeah? So if we want to do the same problem that we have calculated, yes, right here, like going from this guy is a minus 1.25 to minus 2.3. So if we go from minus 2.3 to minus 1.25, we're going to get around here. So that's 9.49 is 9.5 percent that we just calculated. Yes, here. And then of course another one is going from 0.3 to 0.4. So 0.3 and then go to 0.4. Okay. And that's going to give you this little tiny area, which is 3.75, which is 3.8. So that's our calculation is correct. Here. And then 1.25 to 1.5. So you go 1.25 to 1.5 here. Now that's going to give you this little area. Okay. So now you know how to be able to find. I give you so many different examples. Your Excel. And you also have this other people contributed to the common knowledge for everybody in the world that you can use. So you can check if you want to check your data of the company or whatever. You can be able to see visually. This is very good website because you can be able to see it visually like this. Okay. All right. Now let's go back to our lecture. So I stick, okay, there's an online, the website is right here for you. All right. Then that's the same thing that I just show it to you. So here of course we'll have to change. Okay, this got to be actually 3.8. So now I correct it. So that's a 3.8% because you got like a 3.75 is about 3.8 here anyway. So I should change this as well. So anyways, I changed this 3.8 for you guys. Alright, then we'll get into the example. So here we have a mean of 51.4, right? The one that we always use 0.2 millimeter for your standard deviation. So we measure a bunch of parts. And then we're going to use Excel to calculate the mean and standard deviation of the parts. So the customer wants to know what percentage of the parts will be between 51.0 millimeter and then 51.8 millimeter. Yeah. So usually you put everything in terms of the mean and the standard deviation. So in this case, we're going to ask like what percentage of the parts will be between -2, okay, standard deviation, and a +2, which is a 2 standard deviation relative to the mean. So we're going to find around here, yeah, this area. So let's take a look at how we do it. So what we're really asking is what is the area under this curve between here and all the way to here. So we got to use Excel, or you can also use the online to the website that I just gave it to you, or you can use your old old school book to figure out the area between here and there, that 2 standard deviations away from the mean. So we could use the same tools to figure out the area in the tail to the left. So starting from here to here we find this, starting from here all the way to here we find that, and then you minus that, yeah. And both methods is going to give you the same answer. If it's different, probably the book is going to be a little bit different, because the table depends on the manufacturer of that book is going to write whatever accurate or accuracy that they're following. So anyway, and so here the method 1, we're going to use it online. We go there, and I have just already showed that to you. So you put -2 and then +2, okay, like that. So if we go in there, we're gonna just put going from -2 and then go to 2, okay, and it's gonna give you this area, and that's 0.9545. So let's see like what they get. So 95.45, the same. And then we're gonna stick it -2 and then +2. So the second way that we can do is first we can see, all right, each area. So we can go like below -2. We can find this area below -2 instead of our normal way. So we can just go and change this. Yeah, if you want to see the area below, we can see that. Yeah, so that's going. If you go all the way to the +2, you're gonna see this. Yeah, so you can minus this -2 little area out of that, okay, big area. So first you write down that is 0.0228, and +2 is going to give you 0.9772, and then minus 0.9772 minus, okay, 0.0228, okay. So I'm just going to come back here. So that's what we're showing you here. So if you minus that, so this is same as 0.0228, okay, and you are going to get the same area, which is 95.45%. And here is he is using this side and then that side. So what he did is first calculate that area below, and since your normal distribution is always symmetric, yeah, you're gonna get the same amount of area from here to here as well. So that's times 2 will give you a 4.56, yeah. And then you're gonna minus the entire area is 100. So we will chop this and that part out. So that's a 4.56 out of 100. It's going to give you the same 95.45. Yeah, so you can do several different ways. Now the customer wants to know what percentage of the parts will be between 51, okay, 0.1 and all the way to 51.2, this little tiny area. And we are going to do the same thing, yeah. You can convert these into standard deviation, because the standard deviation is needed for you to be able to use and calculate it. So these are standard deviation. Now we're given the real world problem, so we have to transfer that into standard deviation. So standard deviation is again the distance measured from the mean all the way to here. So we have to try to find from here to here what is the distance, from here to here what is the distance, and then you have to minus that. So 51.1 is 1.5 sigma below the mean, and then 51.2 is 51.2 is going to be a 2 sigma below the mean, okay. So if you don't understand, okay, I don't know, okay, how to calculate, it's pretty easy. First, one standard deviation is 0.2 millimeter away from the mean. So your mean is 51.4 and we want to go to 51.2. So you go here, yeah, and this is 51.4, all right, minus 51.1. Yeah, so your mean is 51.4 minus 51.1 is going to give you 0.3. And the same thing, you do 51.4 minus 51.2 is going to give you 0.2. Okay, so you go 51.4 minus 51.1 is going to give you I should have written 51.2, sorry, here, and you're going to give it 0.2. yeah, and then you're gonna divide this with 0.2 because 1 sigma is 0.2 millimeter away. Yeah, so therefore you go like this guy divided by 0.2 millimeter is for 1 sigma. So how many sigma is in 0.2 millimeter? You got 1 sigma. If you have like 0.5, yeah, 0.3. So you go 0.3 divided by 1 sigma is 0.2. So therefore for 0.3 millimeter, we have 1.5, yeah, sigma. So this is how we get this calculation right here, yeah. So you have 1 sigma for 51.2, and then you have 51.1 is 1.5 sigma. Yeah, so here this is wrong, okay, so let me write this down. He got here right, yeah, this is wrong, so let me change that. Okay, so now we get it correct, yeah, 51.2 is 150. 1.1 is going to be 1.5 because 51.1 is far away from, it is farther than 51.2, okay, against this 51.4 median. Yeah, this is nearer and that's farther. So therefore 1 sigma and that's 1.5 sigma away. So now we get the sigma value. Yeah, this is on the what? On the left side. So therefore you put the negative. Yeah, and then you go to this minus 1.5 to 1 to this website. Yeah, and let's just do like between. So minus 1.5, and then we're gonna go to minus 1. Yeah, and you're gonna get 0.0918. Okay, so that is your probability. All right, so here we calculated, you know, if you want to use a NORM.DIST, this is the same problem. First we calculate 51.4 minus 51.1, which I have already shown you here, yeah, and you get 0.3, and then you divide with 0.2, so you get 1.5, and you do the same thing, you got 1 here, yeah. And if you use this, you just calculate it 0.09, that's a 9.18%, okay? So 9.18%, we got the right thing. If you do want to use a norm, right, NORM.DIST, we can also do that. Yeah, you know that every time we do the norm, you understand that you will have to, okay, so you can do 2 times and minus it, okay? So you go norm, right, and let's just go with 1 by 1. And then you do true, okay, and then you're gonna get that. You know, we do the same thing for the second one. You're gonna get this, and then all you have to do is subtract it, okay, and you're gonna get that. Or you can also put the same function. Yeah, if you want to calculate the same function, you can also do the NORM.DIST like we just show you. Yeah, and you're gonna put your 1.5, which is farther away. Yeah, farther away, and then 2, because farther away is going to give you more, call another NORM.DIST. Farther away is going to give you, yes, area, yes, which is going to be, I would say you can do this way. Just, I need to, okay, I might not need the bracket. Okay, let's just do it without the bracket. Trying to, yeah. And then of course, true. Okay, one moment. Sorry about that. Yeah. So anyway, so this is what we input here. Yeah, you can see the NORM.DIST, and then you're gonna start with 1.5. and then this is actually, if you look at it, this is your 51.1, all right, millimeter, and then this guy is your 51.2 millimeter, yes, cut line. So you can also do, which we just show you here, yeah, that I am doing it right here in the Excel formula instead of going one by one and then subtract it. You can also do it directly, so NORM.S.DIST, and then make sure you put your bracket and stuff like that. Sometimes you need it, sometimes you don't need it. Right now mine is I think. And then of course you go ahead and select 51.1, and then you go to 51.2, all right, and you minus that, and you are going to get this, okay, 0.918, and which is, if you turn that into percent, you're going to get 9.18, okay, which is the same answer that we get right here. Yeah, so when you write it down here, it's a little bit difficult for you to be able to see it, yeah, but you can do in the way I did it, or you can do with a negative, okay, just like that. So if you go with the negative, just make sure that you start from the bigger area, yeah, bigger area. So let me show you. So if you go from the negative, it's better that you start, okay, from, if you see like -1, then you're going to see the area like that, okay. If you go minus 1.5, yeah, you're going to see the area reduce, yeah. So therefore you have to go with a bigger area if you use a negative, okay. But in either way it's okay. I didn't use a negative, I use a positive value here, yeah. So which is because I'm going with the positive value here, so that's up to you, whatever you want to do, yeah, but it should give you the same answer, yeah. It's a little bit tricky the way that you handle the negative, and I can show you, yeah, if you want to use a negative value for the norm, this you can go like, okay, going from minus, yes, 1.5, and then true, and then minus, and then you do the NORM.S.DIST, okay, here, and then go on another one, which is this guy. So this is going with a negative value. You know, see, the negative value is going to give you the negative, okay, but it's the same thing. If you call the absolute value, you should be able to get the same thing anyway, yeah. So that's what this is showing you, okay. So all you have to do is just change, okay, change and play with it, and you should be able to get it. Here is, if you go with the negative value, you go from -1, which is a bigger area, minus a smaller area, which is farther away from the mean, yeah. So this is -1.5 is far away from -1, because you can see it, yeah, -1 is here and -1.5 is farther away from the mean, so the area reduced. See that? So that's what we're playing at, okay. You can also take this out, yeah, and call the absolute value, yeah, absolute value of it, and because if you go with that, you can get the negative, but you can always call the absolute value, you know, which is ABS, returns the absolute value, and then give it a little bracket like that. So there are many ways that we can play with the numbers, yeah. So many different ways. I have just show you how to calculate it, and you can practice one of them, yeah. Okay, and then let's go to, this is from your website. It's just showing you what I have just shown you. You put in, yeah, -1.5 and then 1, which is this guy here, is going to give you the area directly, okay, which is the easiest way for you to be able to do that. So anyway, those are the different, yeah, calculations that you can be able to do. Okay, example 2. Now the customer wants to know what percentage of the parts will be larger than 43.15 millimeters. So we are now here, yeah, so 43.15. We want to know like how many parts are larger, yeah, what percentage of the parts are larger than 43.15 millimeters. So from here all the way up. So we have to find that. So this value is above the mean, so we got to convert this to standard deviation. So first we're gonna find, yes, the distance, yeah, from the mean. So your mean is 52.5. our cutoff is 53.15. Yeah, so you're going to minus 42.5 from 43.15, so you will get this, which is 0.65. Yeah, divided by your sigma is 0.3 this time, so you get 2.167. Yeah, so that's the distance from here to here. So we have 2.167 sigma from the mean to the end of 43.1. Yes. And of course, we want to know the area here, so we gotta chunk out the whole thing here, yeah. But now we got the cutoff. Yeah, the cutoff is from here to here is 2.16. So we're gonna call our NORM.DIST and give a 2.167 positive, and it's gonna give you this, all right, probability that is on the left. You don't have to calculate this, because again, your reference, all right, reference is the beginning of this little tape. So if you put 2.167, sigma cutoff is right here. Yeah, so therefore if you put 2.167, it's going to give you from here all the way to here. So if you look at it, yeah, and here we want to give a 2.16 something. Let me see. Yeah, 2.167. Yeah, 167. So that's the area. Yeah, so now the question asks you above that, so therefore we need this area. So 100 minus that area, which is 98.49, is going to give you 1.51%. okay, 1.51%. So when you go back here, you can check it. Yes, so if you want to get the area above, yeah, you 2.0167, you're gonna get that. Okay, so area above is 0.0151, which is the same. Yeah, so 1.51%. So this is giving you the decimal. Yeah, so therefore you have to multiply this with 100. I have already trained you how to go back and forth, yeah, between the decimals. So if you have like a 0.0151, so you go, I'm gonna just add it here for you, 0.0151. So here your decimal practice, yeah, you're gonna do this and times 100. It's gonna give you 1.51%, yeah, which is this guy. All right, so 1.51% of the parts will be larger than 43.1 millimeters in whatever parts they're measuring here in this example. Okay. So now, example 2, using the online thing, which I have just showed you here, is pretty easy. So we do the same thing. First, we calculate the distance, yeah, and we get a 2.167 for the standard deviation, yes. And then we go in here and put a little above and put your 2.167, and you're gonna get that area, which I have already shown you here. Yeah, so if you look at the curve on that, you can be able to see it. All right, and we come to the same thing. Yeah, this is decimal, and then change it into percentage, so 1.51%. All right, well, I think that's it for your statistics review for this class. Yeah, and I think you should be good. And you're supposed to have a course taken from the science mathematics part. Yeah. So anyway, so example using the graphical techniques. Here, if you have like this is 1.25 standard deviations, and you can be able to get it here. You can also put it into the online 2 here, 1.25. Yeah. So 1.25. I just want it below. So here, yeah. That is going to give you 98.49. Okay, so and that's what we're talking about. Of course, here is a different graph, so therefore you have about 90% for 1 point, okay, and 1.25 for this area. Again, as it depends on if you're using Excel, or if you're using the book, or you're using this given graph, or if you're using this online tool here. Slightly different, but it's about the same thing. Because this technique is a graphical technique, so you have to use a given graph to answer the area. Yeah. So here with this graph is showing you around 90% of the parts is going to be on the left. Yeah. So therefore you have 10.1 10% is going to be on the right of this. Okay. So if you want to go with 90, then that should be 10. Yeah, if you want to go with 10.56, that would be like 80 something. So if you calculate it, you get 89.44. Yeah, so I can change that. So I changed that exact one for you. But of course, if you do it graphically, it's about 90%. So you have about 10%, yeah, if you calculate it correctly. So whichever way you want to go, you understand the various way of calculating, yes. And I have given you everything here, yeah. So this is a relatively part 4. Okay, it's gonna be around here. Let's just say part 4 here. And I'm gonna upload this Excel for you, so you can study with it. Okay, from here, starting from. So that's all of the review. Yeah. So this is review stat for this course. Okay, well, that's it for today. Yeah, I'm gonna go ahead and stop here. Make sure you study and study everything you needed. Yes, I'll give you the GD&T review if you haven't done or MET 101 or MET 201. You need it. Yes.